Hey guys, so let's take a look at solving trig equations. So pretend your trig equation is just an x. You solve it just like any other equation. Get your variable, or in this case trig function by itself, and solve. However, you do need to check for your extraneous roots on these things. Also, there's infinitely many solutions technically to all these things, so we're going to be given an interval. Two things you get from your interval. First, we're dealing with degrees or radians. Second, where you're looking on your unit circle. For this class, we're only dealing with answers that are going to be on the unit circle. So let's get started. 6 sine theta minus 3 equal to 0, given the interval 0 to 360. So that tells me two things. First, we're looking at degrees. Second, we're looking at the whole dang unit circle. So 6 sine theta minus 3 equal to 0. Get that sine theta by itself. 6 sine of theta is equal to 3. Sine of theta is a half. 3 over 6 is a half. So now let's pop open our unit circle. And we're looking for sine to be a half. So sine's our y value. So right here at 30 degrees, that's one answer. Theta is 30. Let's keep looking. Here, sine is also a half at 150. Let's keep looking. Here it's negative half, so that's not it. And negative half there, not it. So we've got two possibilities here. And again, yes, we should check for extraneous roots. I'm not going to check every time. Most of the time, if you just have one trig function that's not tangent or cotangent, you don't have to worry about extraneous roots. But let's just get in the practice of checking them anyway. So 6 sine of, make sure I'm in degree mode. I am. 30 degrees minus 3, 0. Change that 30 to a 150. Still works. We're good. Both solutions are correct. All right, 0 to 180 this time. Still degrees, but this time we're only looking at the top half of the unit circle. I need to get cosine by itself. Subtract 5 from both sides. So negative 1 equals cosine of theta. Check the unit circle. Where does that happen? Right here at 180. Cosine is negative 1 at 180. So theta is 180. And yeah, that's negative 1 plus 5 is 4. Don't need a calculator to check that. All right, now tangent. I'd always suggest checking tangents because, you know, that's sine divided by cosine, so you actually have a fraction in there. All right, let's see. Divide both sides by negative 2. We get tangent of theta is equal to negative square root of 3. This time we're still in degrees, but we're looking at the bottom half of the unit circle, 180 to 360. Now, unit circle doesn't have tangent on it. It's got sine and cosine. But we know tangent is sine divided by cosine. So to get our tangent values, we divide the sine value by the cosine value. And I need negative square root of 3. So that means I need right here, square root of 3 over 2 on top. Let's try that out. It needs to be negative, and we need to be down here. So, right, let's try this one. Calculator. Negative square root of 3 over 2 divided by a half And indeed, we get negative square root of 3. That's what we're looking for. So tangent of 300 is equal to negative square root of 3. Now, another one that would have worked would have been right here, the 120. However, our interval said only look in the bottom half of our unit circle. So let's check this. Negative 2 tangent of 300 is 2 square root of 3, which is what we wanted it to be. Okay, subtract 3 cosine theta from both sides. And subtract square root of 2 from both sides. I get 2 cosine of theta equals negative square root of 2 divide by 2 cosine of theta equal to negative root 2 over 2 degrees, and we're in the first through third quadrants. So I know cosine's negative in quadrants 2 and 3, so I'm going to check over there. Negative square root of 2 over 2, negative square root of 2 over 2. So 135 and 225. Check it out. 5 cosine of 135 plus square root of 2. And that is negative 3 square root of 2 over 2. 3 cosine of 135 is the same thing. So it works. And I can check the other one. It's going to work. All right. This time we're dealing with radians. So I need to add sine of theta both sides. Two sine theta is equal to 2. Divide both sides by 2. Sine of theta is 1. Look on your unit circle. Where does that happen? Hopefully you know already. If not, go look at it. Over 2, sine is 1. That's the only place on here where sine is 1. So between 0 and 2 pi, that's the only option. And yes, I do need to have pi over 2 as my answer, not 90 degrees. Now let's see how we could check this. We're dealing with radians. So right here, we're in degree mode. Shift mode, number 4, sets it to radian mode. So now if I were to do this previous problem, you get a whole random different answer. Who cares? Sine of pi over 2, we know that's 1, is 1. 2 minus sine of pi over 2 is also 1, obviously. So this one we could have easily checked in our heads, but just to see that you need to change to radian modes, I did it in the calculator. Okay, solve this guy. 2 tangent of theta equals 2. Tangent of theta equals 1. Well, that's lovely. I know that tangent sine over cosine, so I need it to be the same thing for sine and cosine. That happens at my pi over 4s. Looking in between the second, well, just looking at the third quadrant. Or the second and third quadrant. This half of the circle. For 1. It's going to be negative here, positive here. We have the same thing divided by itself. Anything divided by itself, even if it's some weird square root, is going to be 1. So theta is 5 pi over 4. Right. Let's see what's next. Okay. So we're looking at this. I see, oh, hey, I got a GCF of sine of theta I could factor out and solve it that way. Even easier, though, it's a quadratic. Yes, it's got sine in it, but it's a quadratic. It's x squared plus x. Just the x is sine. Who cares? So we can use mode 5-3. 1, 1, and 0 for my constant. -1 and 0. Let me run that again. -1 and 0. And that's what we should get for what sine of theta equals. I'll go ahead and factor it out so you can see how to do it that way, because we will need to factor out later anyway. We both got a sine of theta in common. Leaving with sine of theta plus 1. So sine of theta equals 0. Sine of theta plus 1 equals 0. I mean, sine of theta equals -1. You see, that's exactly what mode 5-3 gave us. 0 and -1. Again, that's not our answers. That's what sine of theta is equal to. So we know sine of theta is equal to 0 at our pi's. 0, let's go back and look at our directions. Then copy them down. So 0 to 360. So 0 degrees, 180 degrees. This is 270 degrees. At 0, sine is 0. At 180, sine is 0. At 270, sine is -1. And that's our answers. You can check them out. This is easy. 0 plus 0 is 0. 0 plus 0 is 0. Over here, -1 squared is 1. Minus 1 is 0. It works. You could, of course, type that in the calculator. Just make sure you're in degree mode. Okay, number 8. This one we definitely need to factor out a cosine. I'm back to a tangent theta plus 1. And remember, it does need to equal 0 before you try and start factoring anything. Cosine theta equals 0. Tangent theta plus 1 equals 0. Which means tangent theta equals -1. Cosine is 0 at, we're in degrees, so 90 degrees, 270. You can check the unit circle, 90, 270. And tangent's -1, well, that's after pi over 4s that are opposite signs. So here, 135. And down here, 315. This time, we're going to definitely check it in the calculator. I know for a fact we're going to have some extraneous roots here. Make sure you're in degree mode because we're typing in degrees. I'm currently not. Cosine 90 times tangent of 90 plus another cosine of 90. And we're going to get an error here. Let's think about why we're getting an error. Tangent is sine divided by cosine, right? Cosine is equal to 0 right now. So we're dividing by 0. Can't happen. So we know both of these are out. These two will work. You can type all those in if you really want to. I'll do one with the 135 so you can see it does work. Let me get 0. Yeah. So these, this one, this one, this one, this one, this one, this one, not that. These next two are all, they're exactly the same. They're just totally the same. Mode 5-3. It's a quadratic, y'all. Just use your quadratic formula. Sure, you could factor it, but why bother? Degree mode, yeah. Mode 5-3. I've got 1 sine squared, 3 sines, and -4 for my constant. 1 and -4. So sine of theta equals 1, sine of theta equals -4. Now, you should know something about sine and cosine. The biggest they can get is 1. Smallest they can get is -1. They fluctuate between these values. So there's no way on earth you can get a -4. That's extraneous. We just need where is sine of theta 1, and that's at 90 degrees. Not interesting. Let's try this one. This is a little more interesting. So again, mode 5-3. I have 4 cosine squareds, 0 cosines, and -1 for my constant. Half and -1/2. So look on our unit circle. Cosine's a half at 30 degrees, and again at 300. $150 and 210, it's -1/2. Oh, sorry. We're looking for cosine. I was just looking at sine, so these are all wrong. We're looking for cosine as a half. That's the x value, so that's 60 and 300. 120 and 240. So we could check them, but we really don't need to. It's either going to be a half or a -1/2. If we square that, it's going to be a fourth. 4 times a fourth is 1. 1 minus 1 is 0. Done. Let's see. Okay, let's look at this one. So get everything to one side. I like my my quadratic, my square to be positive, so I'm going to get the things to the left side. Type in the calculator. 1 and negative 1/3. So sine is 1 at 90 degrees. Sine is negative 1/3 at, I have no clue. It's not on there. Again, for this class, we're just going to worry about the ones that are on the unit circle, so this will not happen on your assessments. But we can figure out what it's going to be. We're in degree mode. Sine inverse. We could do negative 1/3, but let's just do 1/3, because if we do negative 1/3, we're going to get a negative answer. Let's just do 1/3. And that's 19.5. But I need to fix that to be in quadrants 2 and 3. So that's 19.5 degrees away from the x-axis. So 180 minus that should be the answer. No, plus that. Yeah, because sine's, that would be quadrant 2. We need quadrant 3. So 19.5. 180 plus 19.5. 199.5. Let's check that out. What's sine of 199.5? 0.3333. Yeah, negative. So that's about negative 1/3. Also in the fourth quadrant, so 360 minus 19.5 would be 340.5. Again, that's kind of close. That's not going to happen. We're not going to worry about that. Don't worry about it. It can happen. It will happen, just not in my class. Now we get to some interesting ones. Now we got to use our identities. So cosine of 2 theta's got some options. This thing's a sine squared. I want one trig function. So I'm going to turn this into some sine. 1 minus 2 sine squared theta sounds good to me. Let's rewrite it. Instead of cosine of 2 theta, I'm going to write this. Combine my like terms. Distribute. So we get, yeah, that's going to work. Negative 4 sine squared theta equals negative 1. I'm going to make it a quadratic. It's quadratic. I'm going to get it in a standard form. You could also use the square root property if you prefer, but I think this way is going to be easier. Mode 5, 3, negative 4, 0, 1, half and negative a half. That's what sine of theta is equal to. So half and negative a half, use your unit circle. Degrees, we're going to go 0 to 360 on these. We're just going to stick with 0 to 360. 30 degrees and 150 for the half. $210 and $330 for the negative half. And they'll all work out for us. This one, we don't have any options. So just sine of 2 theta, I know that one. That's 2 sine theta cosine theta. Factor out the cosine theta. Left with 2 sine theta minus 1. Cosine theta equals 0. 2 sine theta minus 1 equals 0, so sine of theta is a half. Find out where that happens. That happens at 90 degrees and 270 degrees. Half, we just did that. It's 30 and 150. Again, we got multiple trig functions. You might want to check it. I think it's going to work. You can check it if you really want to. Here's the ones I definitely want to check. They got a tangent or a cotangent in them. So this is actually pretty easy. We can rewrite tangent as sine over cosine. That's just going to cancel out these cosines. We're left with sine of theta minus sine squared theta equals 0. Reorder that. Sorry, got lost there for a second. Negative 1, 1, and 0 for my constant. X is 1 and 0. So sine of theta is 1. Sine of theta is 0. Is it 0? Yeah. So this happens at 90 degrees. This happens at 0 degrees and 180 degrees. Think about tangent. So we always check with the original. Tangent is sine divided by cosine. What's cosine at 90? 0. That means this is not going to work. That's extraneous because we're going to be dividing by 0. Right here, though, tangent of 0 and tangent 180, they're both 0. So we got 0 minus 0. We're good. Yeah, this is the last one I want to do just to see how you type it in the calculator. Check it. Secant 1 over cosine. tangent. So first thoughts for me are that's sine over cosine. That's the quickest way? No, not actually. That's cosine over sine. You could have also used reciprocal identities to just say cotangent is 1 over tangent, and they'd cancel out anyway. But either way you do it, cosines are gone, sines are gone. This is just a 1. So 1 over cosine squared theta minus 1 equals 1. 1 over cosine squared theta equals 2. 1 equals 2 cosine squared theta. Divide by 2. Well, we could divide by 2, but why bother? Let's do as little work as possible. 0 equals 2 cosine squared theta minus 1. Might as well use modify 3 while we can. 2, 0, negative 1. Square root of 2 over 2 and negative square root of 2 over 2. So that's at my 45s. Positive at 45 and, we're doing cosine? Yeah, 45 and 315. Negative at 135 and 225. Now this one, if you check them all, they'll all work out. Yay. Let's just check one in the calculator just to see how we type it in there, since there's no secant or cotangent buttons. I guess we'll just do the 45. What is secant? Secant is 1 over cosine. We're going to type it in the original. That's secant squared right there. Tangent and cotangent again is 1 over tangent. And we get 1, which is what it should equal. And it'll work for all 4 of those. So if you're typing secant or cosecant or whatever in the calculator, it's just the reciprocal identity you're going to use. So it's 1 over whichever trig function. All right, that should do it. See ya.